Hello out there, and welcome back to another edition of the homeschool educational supplement that we know as Interesting Stuff, where we dive deep into topics that other people usually don't cover. And so today, what we're going to have a look at together is gravity and equations. Why is this important? I hear you ask. Or maybe I just wish that you would ask. Well, it's a subject that we don't think about very much, but obviously forces are acting on us all of the time. And the most consistent of these is gravity. And it's quite useful, as you can gather if you look around and see that things are not floating in the air. They're usually fixed in one place, which is quite practical. So with gravity, you can't see it, you can't touch it, but it's the force that holds us together, keeps us on the surface of the Earth, keeps the planet in a stable orbit around the Sun, and generally keeps the whole universe in order. And believe you me, we need some kind of order out there. Now, to learn more about this, we need to know a little bit about Sir Isaac Newton, who was an English mathematician, physicist, astronomer, theologian, and author, who lived around about 350 years ago. And he is widely considered one of the greatest mathematicians and most influential scientists of all time, and a key figure in the scientific revolution. And not only was he a key figure, but he was also a bit of a revolutionary as well. But how we remember him today is through the story of his observation of an apple falling from a tree. Have you ever sat near a tree and waited for an apple to fall? I tell you, if there's not a strong wind blowing, you're going to be waiting a long time. Anyway, seeing the fruit fall led him to come up with his universal law of gravitation, which he explained in his Principia, a book published in 1687. His law states simply that everything attracts everything else. The strength of the force of attraction can be calculated if you know the object's masses and the distance between them. And it's crazy that equations and ideas that we take almost for granted, using them every day in school, well, once upon a time they didn't exist at all, and the great minds on the earth would argue about their existence and their relevance and their benefit. And so we really do stand on the shoulders of giants. Anyway, Newton's law remained from when the Principia was published until a man called Albert Einstein came along in the early 20th century. Published in 1915, Einstein's theory of general relativity. And because I'm a pedant about these things and information, I love the fact they put in theory and general into that title there. In fact, although it was published in 1915, Einstein spent most of the rest of his life trying to actually explain his theory to people. And what he proposed was that the warping of space and time caused the apparent attraction of objects. This showed that two objects, which one would expect to travel in straight lines without getting closer to one another, if they followed those lines, would actually become closer, because the straight lines became curved. Now, despite that simple explanation, my brain wonders, what would happen if the lines curved away from each other? Do they only curve in one direction? Perhaps I'm asking too many questions. Perhaps I should just accept it. Okay. Anyway, moving on and taking a step back to Newton's theory and its accompanying equation, which if you want to know is F equals g times mass 1 times mass 2 over r squared being the distance between the two objects. There you go. Newton's theory is simpler, apparently, and still used today, but Einstein's theory remains dominant because it explains certain anomalies not covered by Newton. See, there's even anomalies in there as well. The interesting thing about science, of course, is that it's constantly upgrading its ideas and changing them to make them better. It's not completely fixed. So I love it when I hear people say, all of the scientists agree, because I'm always thinking, yeah, I'm sure there's one or two that don't. Anyway, an additional idea to think about is that in a vacuum, which is a space with no air, I'm not quite sure how they get the air out, but there you go, all objects are affected by gravity in the same way. So, for example, a ping pong ball and a cannonball would, when thrown, fall to the ground at exactly the same speed. And how bizarre would that be? Of course, you can't really live in that kind of space. Moving on to check out the equations, which are helpful because they supply us with universal constants, things that we can hold on to when we're trying to figure out how the world works and what our place in it is. Now, all the sciences rely on mathematics to help them make sense of the world, and everything we do can be illustrated or explained using mathematics. Whether it is working out how long we have to wait for the next bus or predicting when an asteroid may hit the Earth, mathematics is vital. Yes, even when measuring your cooking or deciding how many hours of study to put in before the next test. Early mathematics was purely to do with everyday elements of life such as commerce and farming. But once it was realized that mathematics could be used to describe the world we live in and predict its outcomes, its possibilities became infinite. Yep, just about as infinite as the numbers we use as well. There is a beauty and simplicity to mathematics which does not exist in some of the other sciences. For example, the golden ratio is a mathematical concept crossing over into other disciplines and setting standards for it. And the most common example of this is applied in art, where it states that a line with a total length a plus b is to the length of the longer segment a as the length of a is to the length of the shorter segment b. Did you get that? Isn't that just really confusing? Well, how do I explain that in a more easy to understand way? Well, if you've ever seen a classical painting, the Mona Lisa, you'll probably notice that her face seems to be almost perfect no matter which angle you look at it from. And this is because the whole face is divided into certain ratios. Basically, think about a spiral starting in the center and then gradually growing out equally on all sides. That's basically the principle of the golden ratio, which we find in nature in terms of how things grow from a central point. And that we talk about mathematically as the golden ratio. See, was my explanation better? Are you still confused? Luckily, we've got the internet and Google and YouTube and all the good stuff that we can double check everything on. And don't take my word for it, search, research, triple check, cross reference, do all the good stuff. Find the sources of the information, check them out as well. So there are quite a few equations that are important to learn as we go through life. I don't want to study them in detail here. A couple that everybody will come across, Einstein's theory of general relativity, E equals mc squared. Isaac Newton's second law of mechanics, force equals mass times acceleration. That explains why when a truck hits a wall, it makes a bigger hole than when your bicycle hits the wall. Then there's Pythagoras' theorem, a squared plus b squared equals c squared, related to triangles. Area of a circle, a equals pi r squared, and so on, and so on, and so on. It's numbers and letters that come together to help us understand the world, to help us calculate lives, possibilities, opportunities, to help us make a better future, hopefully. And one more final note to think about, and this one's a bit unusual. Did you know that zero was only invented in the 5th century by mathematicians in India? What this means is basically there was no zero that was used before the year 500. Crazy, isn't it? In Europe, before zero had been invented, all Europeans used Roman numerals to do calculations, although this made it difficult as Roman numerals use symbols and have obvious limitations when dealing with lots of numbers. You've seen those old buildings, right, with the X, V, C, I, and it just goes on and on and on. So obviously they needed a better system. And crazy to think that they hadn't thought about the number 0, which makes you wonder what they said when they had nothing. How did they cope with that? Did they ever have nothing? I don't know. That's a crazy one, huh? Anyway, in my world, do you want to know what my favorite equation is? My favorite equation is me plus no food equals hungry. That's mine. So I'm going to finish this here and shoot off and go and have some food. So there we go. You know what it's like when you start getting hungry, you start thinking about it, plays on your mind, difficult to focus. So get some good food to get yourself in the mood. What's that got to do with equations and gravity? Not much, but still part of life, I suppose. There we go. That was a crazy up and down presentation. I hope you find something of interest in there somewhere. I hope it maybe sparked your interest in something for the future or jogged your memory about something in the past. Anyway, that's it for the Homeschool Educational Supplement for today. There'll be extra questions and comprehension under the video. And wherever you are, whatever you're doing, you make sure that you have a great day. Take care.